Hey there, grade 10s. We're going to be doing the hypothesis right now. Hopefully, you've already done the variables. And the independent variable, you know, is distance from speaker, or I'll say laptop because it's from the front of the laptop, to, I'm saying bottom of phone, because that's where the microphone is. That'd be quite the thing here. And then the dependent variable is the whatchamacallit, sound amplitude. Control variables, I'm going to leave that blank for now. There's various ones. I'm leaving that blank. I'm not going to tell you those right now. As the, it's copy and paste. This is so easy. This on laptop to bottom of phone increases the sound amplitude. Oopsie. Why did I get the sound amplitude? And this is obvious. Decrease. But now I need to go question. I'm putting 3 question marks here for a reason. I'm going to bold these because we need an extra word, because. And the because I don't know. But you will need to do some research, cite your sources. Hint, a form may be helpful. This is physics. There's a formula. Draw a sketch of predicted results on a graph. Decide your graph should be a linear or a curve. Okay. Well, we know it's going to increase. I go farther away, we know it's quiet. Okay. But our aim is also to find the actual mathematical relationship. We're in grade 10 now. It's not just, it's going to go down less. We know that. That's pretty obvious. But how much will it go down less? That's what we're going to find out. So I need to do some searching. Google. Form from amplitude, sound, and distance. Yeah, I already typed this in. I know what I'm doing. And this first one is like actually the best one. So Google did a pretty good job for us. So I'm going to click on this. And even highlighted the part that we want. Google's so good. Indeed, based on what we know about the relation between distance and intensity, the inverse square law, that part we don't know. We can see the relation between the amplitude is A varies with 1 over D. The amplitude is inversely proportional to distance. So this idea of inversely proportional, something as the distance gets bigger, the amplitude will go down less. So we need to know what inversely proportional means. Okay, let's go back to the lab. And we'll decrease inversely. That's a key word. Because, what's the because? Because amplitude, let's just write the formula. We have the formula right here. And they even have a nice little example. I'm going to show you a picture about this too. Where was it? All right, over here. This one. Because, let's paste this in. The amplitude varies with 1 over distance according to, or change my font. I don't like that. I'll do some words here. Then I'll paste it in. And then I'll say according to, I'll get rid of the F. Oop. According to, what's our source? Christopher Dobrin on Claire Trevor School of the Arts. So we're going to have the site. This with Noodle Tools. I'm not doing that Noodle Tools business right now to make this video shorter. That's a previous video that you have. According to Christopher Dobrin. Okay. Draw a sketch of your predicted graph. Okay. Will it be linear or curve? Is it going to be a straight line or is it going to be a curve? I don't know. One thing I could just do is ask Google. Inverse graph. What does that look like? And I'm going to choose image. Oh, well, this is bad. These are actually not bad. Inversely, because I know what the answer should be, and those are bad pictures. Oh, that's gorgeous. That's wrong. That's gorgeous. That's gorgeous. That's right. That's right. That's proportional. Okay. So you can kind of find directly proportional, inverse, so it's inversely proportional. But let's see what our formula actually tells us. And that's why I have this spreadsheet here to the right. We know the formula is this. So I'm going to say distance. And I'm going to say amplitude. I'm not making a proper formula. Amplitude. I spell this right. Tude. And we're just going to have some distance. 1, 2, 3, 4. And I was going to drag this down to, let's say, 10 should be good. So it knew the pattern. Now the formula is 1 over this. So it equals 1 divided by this. And I guess I want to fill down. Do I want to fill down? Yes, I do. Do I want to control my decimal places? Yes, I do. So I use these buttons here. And let's go 2 decimal places. I think that's pretty good. I want to see what this looks like because I need a graph in my prediction. So I need to make a graph, and just so you know, I've never made a graph in Google Sheets. I don't know how to do this, to be honest with you. Help graph. Insert chart. Yeah, give me a chart. Oh my goodness, it's connecting the dots. This is kind of garbage. Okay, what I'm going to do, again, if you're also a Desmos user, this from the previous video, if you're a Desmos user, you can definitely use Desmos, whatever you do in math, if you know what you're doing. If you can use this better than me, you can do that, but that's not good. Instead, let's make this window bigger. Good. I'll paste in this. This one was distance, D. The units don't matter now, I'll say meters. This one is amplitude, A, and the units, we don't know them actually. I'll say meters, why not? And again, I'm going to auto scale from 0. It gives a dot right there. So I'm take this, watch this move. Drag it down so it fits in. A dot right at the end, that's kind of yucky. Let's drag it in so it fits in. Then choose a function. I know it's inverse. There's a bunch of things it could be. It's not quadratic. It's inverse because it's inverse proportional. So I'm going to choose this, which is that same function we typed into Excel. Try fit, and it's going to fit it exactly perfectly. So this is what I would do. I usually use Logger Pro because I really suck at Excel, because Excel and whatchamacallit, Sheets make horrible graphs in my opinion. And so this is what I think the graph should look like. I'm going to put this over in, where did it go? Right here. Paste this, make this graph really small. This is a little prediction sketch graph. It's not the right numbers, like the distances here don't match the distances. I don't know what the loudness is, but the point is just to get the shape. And this shape is inverse. And this is an inverse function. If you know y equals 1 over x, that's an inverse function. And that's an inverse graph. So whatever a formula says, we can model that formula inside of a spreadsheet. If you can use a spreadsheet better than me, you can get a better graph here. But that's a horrible connected graph, dots graph, that's bad. You need a smooth curve. If you use Desmos, or you can do some Google searches to find maybe what the graph should look like, as long as it gives you good pictures, because that's obviously wrong. So you have to make critical thinking choices. And then I need to cite this at the end, but that's not for right now. Cool.